All right. Let's see. Katie, are you on?
I am here.
Hey. All right, super. Well, I will pass it off to Bob to introduce you.
Thanks.
Great. Good morning. Our next speaker is Katie Sewell. She's the lead abalone biologist and diving safety officer for the Washington Department of Fish and Wildlife. Her collaborative team aims to restore Washington's beautiful and endangered Pinto abalone populations. Originally from Southern California, Katie now resides in Seattle, in which she's not diving to restore these marine snails. She enjoys playing water polo, underwater hockey, and exploring the outdoors on her e-bike. And I'll bet that if there were a way to get that e-bike underwater, she'd want to do that too. So Katie, we're pleased to have you here today. Abalone are a really important part of the sea otter story, and I'm anxious to learn what's going on. Thank you.
Yeah, thank you guys. I just had my monitor turn off. Let me see if I can turn it back on. 1 second, please. Bear with me.
No worries.
Let's see here. Sorry, guys.
Well, fun fact is Katie and I went to Cal State University, Monterey Bay together. So this is our first reunion post being
It is.
Otter alum.
All right, let me share my screen.
Go for it.
All right, are you guys seeing that?
Yep.
Great.
Yes, yeah, perfect. Thank you.
Okay, okay. Hi, everybody. Thank you so much for having me. This is really exciting to be here. Yes, as Chanel said, I went to CSU Monterey Bay, and so our mascot was an otter. So I feel very close to otters, and I'm really excited to be here with the Elakha Alliance. So thank you so much for having me. Today, I will be talking about Pinto abalone restoration in Washington State. I have been working here for the past 5 years. And before that, I was at Bodega Marine Lab, working on red abalone and white abalone there, and also green abalone a little bit. And then before that, I was at CSU Monterey Bay. And I just have to shout out, I am from Anaheim. I saw one person in the chat from Anaheim as well. So that's exciting. So let's get started. I'm going to tell this story in 2 acts. The first act will be an introduction to abalone in case anyone is not familiar with them. And maybe if you are familiar with them, it'll be a chance to learn a little bit more about them. So abalone are mollusks. They're one of the most, which are one of the most diverse groups in the animal kingdom. Nearly 10,000 described species. They're also gastropods. They belong to the Haliotis family, which so Haliotis is sea, odos is ear. A lot of different cultures will refer to them as like donkey ear shells or something of that nature. There's over 56 species of abalone across the globe, and even more subspecies. So we think over 100 subspecies. There's also observed examples of hybridization amongst abalone. So different species can hybridize with each other, although it's really rare. Their West Coast USA from Alaska to Baja is home to 7 of these species. And we'll learn a little bit more about that coming up. And they're very long lived. They can live a long time. They have Pinto abalone specifically have lived to about 30 years in captivity, and red abalone, which is a species further down the coastline, can live to about 50 years. And abalone are just like us. They have Well, for the most part, a little different. They have a very famously iridescent shell. You might see them, might be familiar with them in jewelries. And popular use for them is guitar inlays. So you might recognize them from that. They have eyes. A lot of people don't realize, but they have eyes. They have two little eye stalks, and then they have a mouth, which we'll learn more about later as well. They have cephalic tentacles, which is for feeling out their food. The two kind of long, cute ones in the front, and then they have epipodia around that you can see around the shell down here. Chanel, can you guys see my mouse if I move it around?
Yes, we can.
Okay, perfect. And then they also use this muscular foot to crawl around and attach themselves to substrates. So this is a juvenile abalone here. And then the adult version looks like this. So here's the mouth right here with the eyes and the tentacles. Their mouth is made up of something called a radula, which is made of thousands of calcified teeth. Here's an electron microscope photo of what those look like. So you can see the detail in those teeth. And they use that to scrape off algae and kelps, and they sort of clean the environment that they're in. So we know them, their nickname is the Roombas of the sea. So they're super important to kelp forest ecosystems because when kelp and detritus fall to the floor, fall to the seafloor, these guys are the ones that are cleaning it up, making room for new critters, for new algae to settle, instead of just these kind of anoxic areas where things just sort of start just deteriorating without any control. So we call them the Roombas of the sea, and that's the part they play in kelp ecosystems. But as we'll learn, they're also sort of part of the food chain of the kelp ecosystem as well. So this is a little guy munching on some macrocystis, some giant kelp here. Um, and they can have a ton of different sort of designs to their shell, which is something I love about them. And we're not exactly sure what causes such beautiful variations. With shellfish, a lot of times the kelp that they eat can cause some variations. But if you can see down here, just this beautiful like chevron marking, or these stripes that certain ones have, these stripes all along the shell, or the beautiful green or beautiful, red thread-like structures to the shell, is sort of what makes them celebrities amongst the shellfish world. An interesting thing too about their shells is they're really, really strong. So they are made of sort of like circular discs that are on top of each other. And that's actually being studied by some people for like armory and aerospace engineering. They don't crack very much. You would have to put a lot of pressure on them to break the shell. So that's something that they have going for them. You'll also see that they have respiratory pores here. And that differentiates them from animals like limpets. And the theory behind these respiratory pores is when a predator is coming to, try to sort of get these abalone or attack these abalone, they can suction down onto the rock, and these pores allow them to continue circling water through their gills. So it's just a great way to get some water movement through the gills. It's also a release area for their sperm and eggs, which we'll also hear more about later. Abalone also are interesting because while it is rare, they can also form pearls. So if like a clam, if a boring clam tries to get in their shell, they calcify the nacre calcifies over the damage. And sometimes if they get enough damage, or if they get a lot of sand inside of their gills, that can also sort of just under pressure, sort of like a diamond, just create these beautiful pearls. And this pearl is in the shape of its guts, basically. It's a conical gut structure, and so that just gets hardened over time. And so if anyone's ever seen an abalone pearl, you just know that it's just a special thing to see, and it's very unique to them. And of course, as some people may know, they're really tasty. And so this is me and my friend. Actually, I participated in the red abalone fishery in Northern California while I was working on fishery management. And before it closed down in 2017, red abalone are the largest abalone in the world. So that was one of the last fisheries that was open for abalone, was the red abalone in Northern California, which I would love to hear in the chat if you guys participated in. Those can get to, this was one of the record abalone at 14 pounds. So those guys get pretty big. Pinto abalone are a little smaller, and we'll hear about that more later as well. They're delicacies. They're pretty delicious, although they're a little tough. And they're also just harvested around the world. So this is the famous active fishery in Australia, where the scuba divers actually use a shark cage. They swim around this cage with that they can kind of get in and out of to get to harvest abalone. And that's just because there's so much white shark activity there that they can't just like not work if there's a shark in the area. It's pretty nuts. And then in the United States, the fishery was free dive only since about the 80s for sport fishery. And of course, I have to include otters in here. Otters, as we know, do like abalone. They are really smart, of course, and they use tools to get abalone off. So this is an older video that some lucky diver caught of an otter using a rock to sort of like beat the abalone off the rock. And so, oops, sorry. So we do know that otters eat abalone, but there's some research from Monterey as well showing that otters might follow, you guys of course would know more about this, otters might follow in their mom's footsteps from what their moms teach them. So we think that maybe if the moms don't have access to abalone, even if the juvenile cub, I might be saying that wrong, the juvenile otters, migrate to where there is abalone, they just might not have a taste for it. And interestingly, in Washington specifically, we just don't really see otters come too much into the Salish Sea. So a majority of our work is in the San Juan Islands and the Strait of Juan de Fuca, and we just don't really see sea otters too far past Nia Bay out here. And when we have seen them, we have never observed them in Washington eating an abalone, but of course, there's so much area where we just don't see. And so we're just not sure if they're targeting abalone up here, but we sort of theorize that they're not. It hasn't been observed as far as we know. They also have other predators like the Pycnopodia, the sunflower star. And when you put a Pycnopodia near an abalone, you will soon learn that abalone, even though they are snails, they have some speed to them. They have some get up and go for sure. So this was an outplant sire, one of our abalone sites that I dropped down to and was just lucky enough to see this crazy chase. And so this is an abalone that has detected the Pycnopodia, and they can detect them very quickly. And then the Pycnopodia is following the scent of the abalone by the slime trail that it leaves, essentially. And so if an abalone is able to, it can usually outrun the stars, but the juveniles are a little more susceptible. Abalone are also a really, really culturally important species and have shared a really close relationship with First Nations and people and Native American people. These are interesting photos because these are both people from British Columbia tribes on the outside, but their adornments, their earrings are red abalone shells, whose range stops hundreds of miles south of British Columbia. So we know that through trading and through cultural importance, a species that isn't present in British Columbia was somehow got up there and was used as adornments and as sacred symbols. And then also here's a photo from 1910 of a person harvesting Pinto abalone barefoot, I might add, in the intertidal zone up in Washington, British Columbia area. So the native people have shared a very close relationship with abalone since time immemorial. They also, as I said, use them for their carvings a lot of times. And what's interests me so much about abalone is in every culture, even cultures that didn't really meet together, they're always used as the eyes, which is really special. And in the Haida Gwaii Nation, which is an island off of British Columbia, they actually say that the abalone shells are the last things to go into a carving or a statue. And once the eyes are, once the shells are attached, that is what actually brings that carving to life. So it's very sacred, very special. And interestingly, the Haida Nation, which you'll see art from here and here down here as well, they believe that abalone came to land and became mice. So they have a close relationship. Abalone and mice are closely related in that culture, and they were meant to bring kind of wisdom to the land. So it kind of awesome little tidbit about them there. They also had, once the area was colonized, they were quickly found interesting and delectable by other people. This is an old photo, I believe, from early 1900s. And if you can see here, it says abalone hunting. So it's just a day trip with some friends to go abalone hunting. And when their populations were more dense, it was just easier. You could just kind of go find them on the rocks there and have a little party about it. And then this is one of my favorites too. So this is from Life magazine in the 1940s, and they went out with a group of people in California and did a whole photo shoot with abalone. Kind of some glamour shots here. I think this is a great engagement photo opportunity here if anyone is recently looking for some couples photography. But they would basically just have a party and have this abalone cookout and barbecue and make tacos. And back then it was just a much more popular species to be harvesting before their decline. Which brings me to the also that to their detriment, the over harvest that occurred as well. So here you can see abalone shell piles that from commercial landing docks, and most of these are in California, when the fisheries were at their height in the 60s, 70s, and 80s. And back then we just didn't know, people just didn't know their biology well enough to know that they're what they needed, how much time they needed to reproduce. And back then the idea was, this is a huge ocean, there's no way we can take too many. They're just standing on piles and piles of abalone shells that were harvested. And so it was a very popular fishery, but it was a sort of a short-lived fishery in the scheme of things. 2 to 3 decades at the height, and then population severely crashed because we just took too many. And then at the same time too, poaching, once there were management laws, of course there is still poaching too to deal with. The reason why overharvest, why abalone are sensitive to overharvest, is because they are broadcast spawners. And what this means is that you have abalone here, potentially male, male with sperm here, female with eggs here, and they don't actually have to touch each other to mate. They just have to be close by so that the sperm and the eggs, those gametes, can meet in the water column and produce larvae here. So their density is important because they have to be close by in order to reproduce. So if you overharvest, you can still have maybe high numbers of abalone, but if they're not close by, we call them functionally extinct because they might be releasing sperm or eggs, but those eggs are never going to meet the sperm. No offspring is going to be reproduced. So over here, this female might be spawning, but no offspring is coming, coming of it. So, and here's another example of just sort of the idea of how they reproduce. And on the top here, you'll see a female releasing eggs, and this is in a hatchery. So it's we use a chemical called GABA to induce spawning for abalone, and on the bottom you'll see is a male releasing sperm. And so we'll learn a little bit more about that once we get to hatchery information. So I got a shout out again to Oregon. You guys do have a couple species of abalone present. So from Coos Bay south, you can find red abalone. The red abalone fishery in Oregon was closed shortly after it was closed in California. And that was sort of a consequence of the purple urchin boom. And if you know anything about that, basically the warm blob that hit the California and Oregon coast in 2015 caused a die-off of kelp and cued a purple urchin spawn event. And so the kelp wasn't able to keep up with all the urchins. And so the red abalone was shut down in about 2017, but they can still be found in Oregon. You also have a very rare abalone called a flat abalone. They're harder to find and harder to come by, but very cool to see if you can find them. They're, as their name shows, they're flat, so they're very, very cryptic and can fit into tight spaces. Historically, there were black abalone seen in Oregon as well, but not since the 1960s. And this is to date now the only intertidal species that we have on the West Coast. So you can see them at low tide in Baja and Southern California sometimes. But that brings me to the star of our show, the Pinto abalone. The Pinto abalone's claim to fame is it has the largest range by far of all of the 7 species that we have on the West Coast here of North America. So it can be found from Southern Alaska all the way down to Baja. And there are some interesting little morphological changes in the shell as you go, as you travel more south, but they are all one species. If you're south of Point Conception, they're called threaded abalone or Pinto abalone. If you're north of Washington, they're called the northern abalone. So Canada calls Pinto abalone northern abalone. So you might have heard of that as well. And so here is where we work. We are based in the southern Salish Sea, and Washington has Pinto abalone are our only species in Washington, just due to the ranges of the others stopping pretty much south of Coos Bay. So they're very special up here in Washington. They're the only one we got, so we want to make sure that they're healthy for generations to come. And then just more specifically for Pinto abalone in Washington, they are not found very far south of this Admiralty Inlet right here, south of about, if you guys are familiar with Kingston, not found south of there. They're mostly up here in the San Juans and then along here in the Strait of Juan de Fuca. And interestingly, in Washington, we have not yet done studies out on the outer coast. There's no reason why they wouldn't be out there. It's just hard to get to. Most of the active fisheries in Washington state happen in the Salish Sea. There's very few people who dive out here on the coast. If you do dive, I would love to talk to you. We have not had any recordings of Pinto abalone on the outer edge of the coast, but it's mostly, again, because of the lack of dive effort out there. But we're jonesing to get out there, though, and check it out. But let's go over a short timeline in Washington to set up our restoration project. So in 1959, we did have a recreational fishery authorized in Washington by WDFW. Again, Native tribes had been using abalone for hundreds, potentially thousands of years. But in 1959, WDFW opened a state-managed fishery. This was sport only. Washington never had a commercial abalone fishery, unlike Oregon to our south and Canada to our north, who both did. Washington never authorized a commercial fishery for Pinto abalone. But again, as I said, within the overharvest, nobody quite knew the biology yet, and it was sort of a non-actively managed fishery, meaning we weren't doing, pre and post surveys back then of densities. We were just said, yeah, go take abalone, of course, here you go. So by the 1980s, fishermen were taking 40,000 abalone from Washington per year based on most of the studies. And poaching also added an immeasurable hit to abalone populations in Washington. This truck was one that was confiscated by our game wardens back in the early 90s. That's all abalone product, as they would call it back here. And then there was charter boats that would take out divers for fun, and one even after the fishery closed, one named itself Abalone Maid, meaning this boat was funded by me selling abalone illegally, basically. So poaching was also rampant. And then 1994 came along, and Washington Department of Fish and Wildlife was like, okay, we got to close this down. We are detecting some population problems here. So in 94, we closed our sport fishery, and it has been closed ever since. Right after us, similar to how Oregon closed right after California closed, Alaska closed their commercial Pinto abalone fishery because they were detecting abundance problems as well. And then in 2004, NOAA lists pintos as a species of concern. And in 2009, the Canadian government lists Pinto as an endangered species for British Columbia. And then in 2013 and 14, actually WDFW petitioned to have NOAA added to the Endangered Species Act. But NOAA declined this, and that is mostly due to, again, going back to Pinto abalone's huge range compared to other species. And we had a lot of information at that time for Washington Pinto abalone, but we just didn't have enough information for the rest of their range, because as you go south, Pinto abalone weren't really as popular because you had larger species to fish, like your reds, your greens, your pinks, and your white abalone, who kind of stole the show down there. And so just not enough data was known range-wide to list them as federally endangered. But after that, we're basically like, well, then let's have them be a state endangered species, because we know what's happening in Washington. We know they're having issues in Washington. We know they don't seem able to bounce back even after the fishery closure. So in 2019, we petitioned for it, and the state accepted it. So in 2019, they were listed as a state endangered species. So that's just specific to Washington alone. And so, there's pros and cons to that. The pro is, that extra funds are channeled to Pinto abalone restoration, and we're able to do more monitoring. But of course, with that endangered species listing, doesn't mean the abalone are doing very well. So overall, it has been a good thing for abalone. And that brings us to our current population status. It needs improvement. So the reason we know that is because in 1992, so 2 years before the fishery closed, scientists established 10 index sites around the San Juan Islands. And what index stations or sites are permanent fixtures marked by railroad spikes in the subtidal seafloor that are nailed into the boulders, so we can go back and measure and find them again. And at these 10 sites, all 10 sites were chosen because there was a very high abundance of abalone there. And so we knew habitat's good, densities are good. We can use these sort of as a canary in the coal mine to see if these aggregations, just to monitor these aggregations, what does the change look like over the years? Even if they move around a little bit, there should still be a consistent abundance at these stations. Or even if one station goes low, maybe another one goes high to account for it. However, in 1992, so in 1994, the fishery was closed, and we believe that for fertilization threshold is around 0.15 abalone per meter squared. That's actually even on the low side. It's really hard to study this because we don't know a lot about, planktonic larval disbursement. but we basically think that there should be about 0.15 abalone per meter squared in order for them to be able to reproduce. So back in 1992, we believed that these index stations were higher than that threshold because in all 10 index sites, there's 359 abalone total. And then as we kept monitoring these index stations, we just kept seeing decline after decline after decline. So by 2003, there was 136 abalone in all 10 stations combined. And then in 2017, we found 12. So those all measure up to a 97% decline in all the index stations combined. And yes, these are just the index stations, but when it's this stark, we can kind of say, okay, we can, these again are these canaries in the coal mine, what's happening with the bigger population. So it was just red flag after red flag after red flag of, even though fishery closure happened, even though there's no active fisheries, even though, poaching is getting under control, poaching got under control basically because you just couldn't find them anymore. So it's sort of a self-control thing. So going from 359 to 12 was a big like, okay, they're not coming back themselves. They have hit a threshold where they are too spread apart. Even though there are some here and there, they're not able to find each other and to reproduce in any meaningful kind of way. At the same time, the size of the abalone on these index stations was getting bigger and bigger and bigger, which sort of sounds good, but that just means it's just a sign that there's no juveniles, there's no offspring coming in. There's no recruitment happening. It's just an aging population of animals here. So that's another red flag of, okay, we might need some human intervention here. They're just not dense enough. They're not abundant enough to be reproducing. Before this year, actually, there hadn't been a juvenile seen since about 2008. So juveniles, anything under 50 millimeters, which is about the size of the animal in this photo. So it had been well over a decade since juveniles were observed in the wild. Which brings us to Act 2. We said, as a group in 2003, we said we're gonna partner up with different agencies, different nonprofits, different universities, because clearly human intervention is going to be needed. We made this mess. We might as well clean it up. The human beings have affected this animal greatly. Let's be the ones to help them out, to get them back on their foot, as you might say. So back in 2003, sort of a cooperative was created, and that cooperative is still growing to this day with new partners every year. So I think it's kind of a special thing because humans have been so deeply intertwined with this species, to sort of make it up to them, which has been a really a special experience, I think, for a lot of these members of the partnership. So we created a Pinto abalone recovery plan, which is essentially just WDFW partnering with nonprofit Puget Sound Restoration Fund, which is based on Bainbridge Island and in Manchester, Washington, if you're familiar with the area. And we said, let's mitigate the loss with our own abalone, essentially. Let's create abalone and outplant them to sites in the wild and see if we can sort of give them these training wheels to use in order to get back to a self-sustaining population. So this isn't like a permanent, let's do this forever. This is let's give them a boost. Let's give them these training wheels. Let's have them form their own aggregations. And maybe these captive bred animals will start reproducing themselves and adding to their population themselves. So we collect, as you can see, we collect abalone here and bring them into our hatchery in Manchester, Washington. in Manchester, they're spawned, like you saw in that earlier video, using some diluted chemicals that sort of put them in like a stress state to spawn them. They survive, they're fine. They live a great life in our hatchery. And then we produce all of these babies, these cute little baby abalone that we raise. We tag some of them. The tagging has changed a little bit over the years. And then we release them to the wild at about 1 to 2 years old. So that is just basically we're saying like, okay, all of these abalone are missing. These abalone are too far apart to spawn to reproduce on their own. Let's add new aggregations. Let's add abalone and see if that'll just give them kind of the running start that they need, that they weren't able to do themselves because we had taken so many. So if any of you are already familiar with abalone, the one quirk they have is that they're hemophiliacs. So when we harvest them, when people harvest them, they use screwdrivers or tools, but that can really injure the abalone. So what we do is we kind of trick them into thinking they're being chased, and that makes them move. And once they're moving on the rock, once they're not completely stuck, when they're on the rock like this, it's impossible to remove them unless I guess you're an otter with a rock. But they are stronger per capita than our hands are to remove them from the rock. As soon as they start running, they can be popped off easily and without any damage. So that's the way we take care of them. We take care of these future moms and dads and make sure that they're not injured in this process. And then we put them in mesh bags and we bring them to the surface. So I have a cameo here. It's about 2 minutes long, and it shows sort of a good overview. The person narrating is Josh Bauma from Puget Sound Restoration Fund. So Chanel, please holler at me if the sound isn't working on this. Otherwise, I'll just play it here.
I do not hear it.
Okay. Let's see. Oh, I think I have to hit audio. Oh, okay. Well, I'll just speak over it. So this is an older video, but still holds true. So this is at the Manchester hatchery. And this is where we raise our abalone. Actually, this is our older hatchery. We've moved since then. And so these are our brood stock that are in our tanks. These are, we're tagging our abalone so we can keep track of them once we spot them in the wild. And then we sort of load them up into these little travel tubes. And that, since they're small, they are a little more fragile than the adults. And that way we can transfer them and keep them safe and keep them from getting, broken shells or injured along the way. We then load those PVC tubes up onto the boat, and we send divers into the water at these pre-selected sites that we have found ahead of time that have great habitat potential, presence of wilds, although that's a little rare these days. And then we just sort of tuck them in. We tuck them into these outplant sites. We put crustose coralline covered boulders. They love the pink algae that you see here. And then we remove the mesh. We now remove the mesh immediately. And we just let them go and say good luck, introduce them to their new home in the wild. And yeah, it's a really rewarding time for all the divers. It's sort of a culmination of a lot of hard work over the years. Everybody loves Outplant Day. It's really special. And you can, hang out next to the tubes, and some of them will just take off. Some of them are eager to check out their new surroundings, and some of them sort of just hang out for a while and are a little bit like, what is happening right now? And then we go back about 10 months later and survey them. And hopefully, this is, a little bit older than the abalone you saw there, but hopefully we see abalone still there at the outplant sites. So what does an abalone outplant site look like in Washington? So this is one of the least kelpy sites. All the other sites are very kelpy. This is just a photogenic site, so I'm using this as our example. But so we choose these sites by doing scouting dives. We have, we go off intel of older dives or where we think we might be, or just what the shoreline looks like, what the depth sounder looks like, and we'll throw divers in. And essentially, it's not the most scientific process ever, because we just don't know exactly what makes a good site a good site. You can have two sites that are like mirror images of each other, and abalone will stay at one and not stay at another. But anyway, we'll hear more about that later. So we go to these sites and we stick four, if we find out, if we think we like the area, we'll stick four railroad spikes or pitons in all four corners of the subtidal seafloor in about we aim for like 8 by 10 meter areas. It's not always perfect, but it's kind of sort of in a square. And then here's you can see the tubes that have been outplanted at this site, nestled in. And then we'll just let them go. So we outplant them, we just leave them there, we let them chill. We don't come back for about 10 months. Other abalone restoration programs, like in California, they've done like 24-hour, 48-hour post outplant surveys. We find that we don't have the resources. It takes a lot of resources, and we have so many outplants to do. And we find that bothering them at that early of a stage might be more detrimental than it is helpful. So we have these PVC tubes tucked in here. We'll outplant anywhere from 600 to 1,000 animals per site. And then when we come back, we have divers who find those four pitons again. They have little polyline that inevitably gets immediately fouled. So we look for that yellow polyline, and we lay out a 100-meter transect tape around the square. And that's just for us to kind of visualize the whole outplant site. And then we make these lanes with lead lines. So some poor diver takes a huge lead line spool and just reels it out up and down to create these lanes. And again, this is all just for our own like human need to have things organized. It has nothing to do with the actual abalone, the lanes or anything. But then the divers will line up two to three to a buddy team. Well, they'll go to the bottom of each lane and they'll just survey and work their way up and just kind of turn over little rocks here and there gently. And you're looking for all these tiny abalone. And so you're noting them when you find them, and we're taking measurements of their shell. If they're tagged, we're noting their tags. And we're noting, any mortalities if we see any. And in that way, we're just doing getting a whole new idea of that site right after 10 months after we outplant it. We also do a perimeter survey as well, so 2 meters outside of the outplant site. And these dives are not only shallow if anyone's scuba divers, so these sites are around 30, between 15 and 45 feet, because Pinto abalone in Washington are found shallower than they are like in California, because they can access that cold water shallower and get more kelp up in the shallow areas. And so these dives are long. You're not really expelling a lot of energy, so you just are sitting. We have heated vests now, so that helps a lot, but these dives have hit 2 hours before. With 120 cubic feet tanks, you can get a lot of air and a lot of time. So these are chilly, cold dives, but they're one of the team's favorite type of dives. So that's what an abalone survey is like in Washington. So as of 2024, we now have 37 Pinto abalone sites established around the San Juan Islands. That equals over those years, since 2009. 2009 was our first outplant. We've outplanted 55,000 juveniles to these sites. That represent 250 genetically distinct families. So we're very careful about making sure we're creating distinct families. We want to replicate wild wild reproduction as much as possible. So that we hold very important. And although it sounds like a lot of abalone, 55,000, that should fix all the problems. You must remember abalone are towards the bottom of the food chain. So it's natural to have a larger amount of mortality. It's sort of like make a million babies so that 100 survive. And so just because we've released a large amount of animals doesn't mean they all, unfortunately, survive, but it's a huge accomplishment for us to have put this many out so far. And 2024 was really exciting because for the first time ever, new partners actually like took over their own outplant sites. So now we have not only Puget Sound Restoration Fund and WDFW maintaining and monitoring these sites and outplanting to these sites, but now we have Salish Tribal Nation, Seattle Aquarium, and even Shannon Point's REU, their undergrad research program, did their own site and actually dove on it for like 48 hours. And we're just really stoked on that. So that is like what we want to see. Basically, we love that this is growing and becoming such a big cooperative of effort. But are the abalone sites working? That's the big question. So keep in mind our barometer for success sounds crazy because it's only 1 to 4% of abalone. Seeing 1 to 4% of abalone when we come back in 10 months is good. It's actually very good. That's successful. That's again, like throw a lot of abalone at a site, and we kind of need sort of not that many need to actually stick per se or survive to have an active aggregation of reproducing abs. So and also we know we're not seeing all of them. We know from past studies that we might even actually only be seeing 20 to 40% of the animals we put there. They're very cryptic species. I mean, they're supposed to look like rocks. So as hard as we try and as much time as we spend looking at all the cracks and crevices, we just can't see under every single ledge just because of the complication and the complexity and rugosity of the site. But B, they want to hide. They don't want to be seen. They're introverts. They stay in their shell. So we know that we're missing some as well. So we know that if we're seeing 1 to 4%, there are more there. And we consider that a success. We've also done individual tagging studies in the past where we know that we go and survey once and then we'll survey again and we'll see an abalone there that we didn't see the first time. So we know we can put that abalone back in the bin of that outplant site because we knew it was there, we just didn't see it. About 2/3 of the 37 sites are successful, which is huge. It's really great, but we just don't know why some sites fail. We're not sure. Again, they look the same to the naked eye. They have the same vibe, if you will. But sometimes abalone we go back and we won't see any, or we'll see one, and that's not considered successful for us. If outplant sites are successful, we continue outplanting to those good sites. So we'll do pulse outplants over the years to keep giving that site more abalone. We also incorporate, we have also been outplanting at age 2, which has been the status quo for the program. And we now outplant them at age 1 as well. So that's been more efficient because we can clear our hatchery for more abalone. And also we think that they might not be getting like domesticated in the hatchery. So in the hatchery, we give them kelp, and we've seen that they sort of get a little like, almost like puppy dogs where they're like, heck yeah, kelp is coming. And we really don't want them to be like excited about shadows over them. We want them to hunker down. So we think they might get a little less domestication that way too. So here's some graphs. Graph time, bear with me. So here is a list of our sites, but not actually a complete list, but a list of some of our sites. And so over time, you'll see, of course, like some of the older sites, we just have more data on, but some sites just happen to be successful, or, some turn out to be successful. And then, which is, over 4% for these 2-year-olds. And then some sites, they just don't stick. They just don't like it there. They migrate away, they pass away, something is happening there. But instead of kind of time sinking too much time into figuring that out. We just are like, we need to move on at this point. We can't figure it out. We need to move on. So we stick with the good sites. We try to find more good sites, and that has been really successful for us in this program. And then the survival. So this is, like I said, we started doing 1-year-old outplants as well. So they're much smaller than the 2-year-olds. And this is just started in 2019. And so we're kind of seeing the same thing. And for 1-year-olds, we say about 1% of survival is good because they're so much harder to see and find again. But we're seeing the same thing. Some sites are total gangbusters. Some they just are really successful right away. It's like obvious. Some are like kind of in the middle, and then like Iceberg was a total great site. And that same year, we picked 2 sites that we called Watchtower and Cottage. We name our sites after World War II amphibious assaults. If anyone's big World War II heads out there, yeah. So and we keep all the GPS positions of the sites the top secret so that we can keep poaching out of the equation. But yeah, so we stick with those sites and we keep outplanting them in future years. And so another important question for us is, okay, so they're successful, but are they growing? We need them to be reaching reproductive size, which we believe is around 50 millimeters or larger that we've observed abalone able to reproduce. So here is the percent of abalone that have reached reproductive size on these outplant sites. And I should say none of them are outplanted at reproductive size. So these are all abalone that have grown to reproductive size. So you'll see on the bottom, dark green, are the percent of abalone on the site that are over 50 millimeters versus the ones that are still sort of juveniles, sort of teens, and are growing larger. And this is also in chronological order. So you'll see that these sites over here just are newer, so that there's a lot more small abalone on there. And then Omaha, Gold, Juneau, and Utah, those were the original 4 sites in 2009, which are all just, they picked them so well back then. They're all great sites. Some of the most successful sites are from the original 4, so that's really cool. And then, so the last slide was percentage, and this is just the number of abalone. So there, again, on Omaha, which is like top dog site, it's an awesome site. There's 140 abalone there that are larger than 50 millimeters. So that is plenty of abalone to create an aggregation. I mean, only really 2 abalone need to be next to each other again to reproduce it, as long as they're male and female. But so some of these sites are just like super sturdy, have become super sturdy aggregations of abalone. We have not observed spawning happening at these sites, but based on a lot of past observations and knowledge, we think that they might be nocturnal spawners, and they like a full moon. So one of these days we have to get out and dive on these sites during a full moon and see if we can observe any of our abalone or captive bred abalone spawning in the wild. Hasn't been observed yet, but it's hard to catch those events. Hopefully they are doing that and are adding to the population. And then why are some not working? Again, we're not really sure. It's sort of a mystery in our program. We don't find a lot of shells, oddly, whether that's because there's heavy currents in Washington and they're blown away, or because they're not actually suffering mortality, they're just leaving. If fish eat them, then fish spit out the shell, yards or hundreds of feet away, and we're just not gonna ever find those shells. So if fish are the predators, then we don't know that. We haven't observed that. They could be leaving the sites, and in that case, we wish them well. We hope they do good, but we aren't going to spend a ton of time going in 360 degrees to try to find out where they went. Oddly, or coincidentally enough, 2 of our outplant sites, we noticed a migration sort of just right off the plot during those perimeter surveys. And so it's sort of funny, like we picked a plot And they were like, well, good try, but we're just going to move like 10 meters that way and hunker down. So on those two plots, we just shifted and followed them. And we created new plots where they told us to, basically. And so, and then the other thing is that, they might just be really cryptic and we're just not seeing them. But once they grow older, they do become emergent, and we should be seeing the bigger ones like you see in these pictures down here. And to get at this, we've partnered with a lot of folks who are doing really awesome research. We have Dr. Eileen Bates here, who just finished her PhD, and she had oceanographic sensors set out at our abalone site, which monitored pH, current, light, temperature, oxygen, and salinity. And long story short, there was no smoking gun on that study, which is probably the best in the long run, because if we would have to test a site for like current for a year before we outplanted there, that would take a lot of resources and a lot of time. But yeah, she did not find anything that really stuck out within the data. She's still analyzing a little bit, and she was hired by a Puget Sound Restoration Fund, so she'll continue that work. We also set out time-lapse photos to determine whether predation occurs, and have 100,000 photos, and not a single predation event has been observed in 100,000 photos. We do think that they might, if the abalone died inside the tube, we've noticed that some little cone snails feeding on it, but we're not sure if that's scavenger or active predation. But fish swim in, fish swim out, and the same number of abalone are in the photo. We've seen octopus, we've seen everything, you list it, it's been in the photo, and there's the same amount of abalone once they leave. And then we also have a range-wide genetic study led by Dr. Jay Diamond and Josh Bauma here in these photos. And part of that study was a study of the genetics within an outplant site. So they actually, this is right before I was hired, because I probably would have died a little bit inside, but they went to an outplant site, collected all of the abalone that we reobserved on the outplant site, did genetic clips of them, put them all back. They all seem fine. They're tagged and we see them thriving years later. And he found that there does not seem to be any like genetic bottlenecking or genetic problems happening on the sites. And all the families that are placed on the sites seem to be having pretty comparable survival rates.
Hey,
And
Kate,
then lastly, oh yeah.
a time check. We've got 2 minutes left.
Okay, perfect. Lastly, at these index stations, we just did another round of them in 2024. And for the first time, we had 13 abalone on all the index stations. So we had one more than we did in 2017, which doesn't seem like a big deal, but for the very first time, we saw more abalone. We also documented a decrease in shell length overall, which means potentially there are new abalone being created in this population. And then in the future, we're just going to continue establishing outplant sites. We might move into the Strait of Juan de Fuca once we learn a little bit more of the population dynamics there. And we have surveys going on actually today. After this, I'm going to do some strait surveys out there to learn a little bit more about the wild population of the strait. And then we're just going to continue trying to figure out why sites some are successful, some aren't. And then just building on our partnerships. This is a huge, huge, huge project. I know in science, it's like collaboration is like a hot word, but we could not do this without a ton of people and a ton of really brilliant minds that are on this case. And so we just keep that goal in mind of returning Pinto abalone to the self-sustaining populations that they once were. And with that, this is just a handful of people to thank. I encourage you, if you want to learn a little bit more, to use this scan code that you see here. It will bring you to our Instagram account, which I'm not just clout chasing here, but our link tree on the Instagram has a bunch more interesting videos and resources there. There's a really cool one that CDOC just did that's very child friendly, very kid friendly if you would like an educational video for kids too. So with that, again, thank you, Chanel and Elakha Alliance. I'm really happy to be sharing the Pinto abalone story with you guys, and happy to take any questions if we have time. And feel free to contact me at this email address for additional information as well. Thank you.
Thanks, Katie, and congrats on working so hard on this effort. It's really fantastic to hear from you because I also follow you on Instagram, and it was really
Yes.
to bring you here today to talk about it. Unfortunately, we are at time, and there are several questions in the chat. So if you have a couple more minutes by chance to just type in the answers to those questions, Katie, I'm sure
Yes, for sure.
all our attendees would be really grateful for that. So yeah, all right.